Hi, questions in analysis in this textbook. Question 1. Let X be the sequence defined by this one. Show that this sequence is decreasing and royal bounded by 0. Let Yn defined by this one. Show this inequality. Deduce the limit xn equals 0. Question 1. Solution. We see that xn plus 1 is less than x1 for any positive integer n. And we see that by the definition of xn, xn is greater than 0 and less than 1 for any positive integer n. We thus conclude the sequence xn is decreasing and royal bounded by 0. Now, we see that xn minus yn is given by this one. We will prove a proposition Gn says the denominator of this one is less than 0. We see that T1 is true. Suppose that Tm is true for some positive integer m. This says we have this inequality. Then we have this inequality. This inequality says Tm plus 1 is true. By the principle of induction, Tn is true for any positive integer n. This implies xn is less than yn for any positive integer n. Note that xn is greater than 0. So we have this inequality. Furthermore, we see that xn times yn equals 1 over 2n plus 1. We then conclude we have this one. Consequently, we have this inequality. Note that this limit is equal to 0. So the limit of xn squared equals 0. Note that the sequence xn is decreasing and bounded. So the limit xn exists. Let the limit xn equals alpha. Then the alpha is a real number. So the limit xn squared equals the limit xn times the limit xn. This gives alpha squared equals 0. So alpha equals 0. This says the limit xn equals 0. Question 2. Let xn be the sequence defined by x1 equals 2 and xn plus 1 equals 2 times xn squared. Show that if the limit xn equals x exists, then x equals 0 or x equals 1 over 2. Question. Does this limit exist? Justify your answer. Question 2. Solution. Assume that the limit xn exists and equals a real number x. Then the limit xn squared equals the limit xn times the limit xn. Consequently, we get x equals 2x squared. This gives this equation. This equation has two solutions. X equals 0 or x equals 1 over 2. We see easily xn plus 1 is greater than xn. And then from this inequality, we see xn is greater than 1 over 2 for all positive integer n. But if the limit xn exists, the limit xn would be 1 over 2 or 0. So the limit xn does not exist. Thanks for watching. Bye.